The following is a conversation with Rushikesh Padsala. I got in contact with Rushi around 2015 in context of a big project in Dubai where I was involved with developing a workflow that combines facility management with 3D GIS visualizations. Just a few years later, Rushi reached out to me and mentioned that he's now living in Stuttgart, Germany. This is, of course, the city where the famous FMX conference is held every year. Since 2019, Rushi is a researcher in geoinformatics at the Stuttgart University of Applied Sciences. Since 2020, Rushi is also pursuing his PhD at the Next Generation Cities Institute at Concordia University in Montreal, Canada. In this episode, we'll dive deep into his research, geospatial technology, data standards, and the real-world impact of his own and his colleagues' work. Stay humble, stay curious. This is the 3D Environment Podcast. And now, please enjoy the conversation with Rushikesh Padsala. Cool, yeah, Rushi, it's amazing to have you on today. Thank you so much for your time. It's a pleasure. Thank you.
Yeah, thank you so much for having me on your podcast series. As a regular listener, it feels like a dream come true to be a part of your show. So I'm genuinely excited and grateful for this opportunity. And yeah, thank you once again for having me here.
Yeah, no, I think we'll have a fantastic episode. I'm really curious to dig deeper into the technical trenches with you on what you're doing. Mm-hmm. And yeah, we've known each other not too well, but for quite some time. So it's definitely a fantastic opportunity to get up to speed also.
Yeah. For sure.
But I mean, not everybody knows you yet. So I would say, please just tell us a little bit about yourself and where you grew up and kind of which education you pursued and so on.
Mm-hmm. Yeah, so I'm originally from India and grew up in Ahmedabad, the largest city right in the heart of Gujarat. That is the name of the state. Mm-hmm. It's all the way in the extreme west of the country. And yeah, let me tell you a big shout out to all the foodies out in Ahmedabad there, because seriously, this city it's like a paradise on a plate.
On a plate.
Yeah. So whether you are into spicy street food or full on like a local Gujarati meal, or even some Indo-Chinese fusion that you definitely won't find in China. Yeah, Ahmedabad is something that probably will make your taste buds do a little happy dance. So, yeah.
Amazing.
So I was the only child. So you know what that means. I get all the attention, whether I want it or not. That means extra serving when I was being good, or all the beatings when I wasn't. But yeah, it was a full on like a roller coaster ride. But yeah, it just builds your character. And for my education, so I finished my high school in 2009. Yeah, which honestly feels like just yesterday. Until I remember how much tech has changed since then. Mm-hmm. And after that, I did my civil engineering and earned my bachelor's degree in 2013, followed by my master's in geoinformatics, GIS and remote sensing in 2015, from the Center for Environmental Planning and Technology. So that's the name of the university, CEPT University in Ahmedabad. And so most of my early 20s were spent in textbooks, maps, computer games, and of course, indulging in all that amazing Indian street food to keep my brain cells firing.
Nice. So now we know where you're taking your energy from. How was it for you kind of when diving into, let's say, technology early on through your youth and then also going through your education, like bachelor's degree and so on, kind of how did you get in first contact with GIS, so the geographic side of computer science, and not just purely software engineering. And how did you discover, you just mentioned maps and kind of this touch of geography. How did this get into your life?
So basically, when I was young, my cousin brother, he runs his own company. He's a surveyor, a land surveyor. And that was, I would say, the first time I got in touch, not with GIS, but more on using satellite maps to plot land areas or land boundaries. I guess back in 1990s, early 2000s in India, there wasn't that much of GIS or remote sensing. But I would say once, I think in my last semester of civil engineering, we had this a very small module on surveying using geospatial technologies. And that is where officially or academically, I got my first exposure in this whole geospatial world. Yeah, and since then, I finished my master's, and yeah, I've always then been into working in this geospatial domain.
Yeah, and so basically then after this, you got into the industry and you worked at a couple places, including where we actually met. It must have been around 2014, 2015, where we got in touch through this project in Dubai, where I collaborated also, or I was involved in with the local Esri distributor, Gistec in Sharjah. So don't remember all of the details. It's been 10 years, right?
Yes.
But so you were working in this company in India back then, because I don't remember precisely the date. No, it must have been 2015. So you were working directly at Gistec, or maybe you just give us a little bit of the side of the companies that you worked at, and we can pick it up later.
Yeah, okay, absolutely. So after I finished my studies, I kind of had to wait about 6 to 8 months before landing my first full-time job. And during that time, I actually volunteered with an Indian corporate, which goes by the name of Adani Groups. And there I used to work on voluntarily. Basically, I used to work on digital bathymetry models to help structural engineers understand sea depths and creating base maps. Basically, they were into development of seaports. So it was actually a great way to keep myself busy when I was actually exploring my first full-time job, which actually paid me. And like it was in early 2016, I would like to thank a referral from Elliot Hartley, one of your previous colleague at Gastel Design in UK. So he referred me to this company, Gistec. And then, I landed my first full-time job in Sharjah.
Yeah.
And as you said, they've been the official S3 distributors and I guess the leading geospatial consultancy firm in the United Arab Emirates for, I think, over 25 years.
Yeah.
And that was the time when we had our first, or when we met for the first time. Yeah. So I was working there as a 3D data analyst. And later as a project lead, and I worked more on the state-of-art 3D geospatial technologies from Esri at that point of time. And it was not only 3D, but it was like more on 3D, but I also used to work on developing 2D geospatial applications, specifically for domain on real estate, urban planning, transportation domain, and so on. Yeah, actually that because it was my first professional experience. So big thank you again to the Gistec team, whether it was mastering the very nitty gritty of the technical stuff or learning the importance of teamwork or figuring out, let's say, how to stay calm when a project takes some unexpected turn. I actually learned a lot. It was also my first time living away from my family in a different country.
Yeah.
I lived there for around 3 years. In fact, it was the first time I ever been away from my city for that long. So it was huge life lesson, a huge personal learning curve, but I would say it was totally worth it. Yeah, and then I left Gistec in mid of 2018, or more or less towards the end of 2018 to, I would say, to chase some of my academic goals in Germany. Yeah, so that's how my professional career has been by the time I came to Germany.
Yeah, that was the next step, to go to Stuttgart. How was that process for you to kind of say, hey, let's go from the industry to academia? And then also, how did you choose where to go? How did this happen? What was that process for you?
Yeah, so switching to academia was a bit of a journey for me. It wasn't a sudden decision, I would say, but I would say a series of steps driven by my curiosity and, let's say, passion or love for 3D geoinformation. The motivation, I think it really kicked off during my time at Gistec.
Mhm.
I was working with some really cool geospatial tech and saw how much potential there was to push the boundaries. And back then, this 3D GIS was transitioning from being just about visualization to something much more dynamic and much
Mhm.
more like a decision making tool. But it was a slow transition, I would say, because I noticed that even many clients, when I was in Gistec, they used to struggle to see beyond just basic visualization and
Yeah.
considered, yeah, 3D as more of a fancy and optional requirement. Yeah. So basically, this sparked my desire to explore these ideas further into kind of an academic research and development of making 3D geodata as the forefront for decision making and stakeholder collaboration.
Mhm.
And yeah, the chance to explore new ideas or contribute to new scientific knowledge and collaborate with brilliant minds in this field was, yeah, it was too exciting to be ignored.
I can fully understand that. How did you then choose specifically in Stuttgart, the University of Applied Sciences? How did you find out about them, and how did you consider that this is the place I want to go?
So choosing Stuttgart University of Applied Science, it was a bit like finding, I would say, the perfect pair of shoes. And in fact, it wasn't my first encounter when I came here in 2019. It was back during my master's studies in India.
Mhm.
So my university, they hosted this AGAC conference, which goes by Applied Geoinformatics for Society and Environment conference.
Mhm.
And a few professor, I guess, couple of professor from the Stuttgart University of Applied Sciences came over to demonstrate their research in 2D and 3D
Yeah,
GIS.
yeah.
Yeah, so that was my first real exposure into the world of 3D geodata.
Mhm.
And yeah, a big thanks to the professor, Dr. Anjana Vyas, who made it possible for me to do my master thesis as an exchange student at the Stuttgart University of Applied Sciences. And a
I
huge
see.
thanks, yeah, and a huge thanks to Professor Dr. Volker Kurz, who then graciously brought me into his team.
Mhm.
And yeah, their support and mentorship have always and will always remain a guiding light in my academic and professional journey.
Yeah, 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 yeah. Professor Kors is also a person that you put me in touch with very kindly, and I had the opportunity to hold kind of two kind of little guest lectures, guest
Yeah.
presentations for some of the students. That was 2 years ago and last year. So yeah, I saw also a little bit into kind of the let's say the work of what they are doing and kind of what the students are learning about there, which is obviously, as we are speaking or as we are going to dive into it, it's a very, very inspiring field that has a lot of potential also. But let's start to explore this a little bit. So let's start talking when you started joining the University of Applied Sciences in Stuttgart. What was your, at the beginning, especially, your main focus of research, and which, or maybe evolving over time, how did the role of the collaboration within the team there and with Mr. Kors, how did this develop over time?
So my main focus of research has been on advancing 3D geospatial technology, particularly in the development and application of urban digital twins. So that has always been my core focus of research.
Mhm.
So basically, urban digital twins are essentially, I would say, detailed dynamic 3D city models of urban environment, which serves as a powerful decision making and collaboration tools. And my work basically explores how these digital twins can be leveraged in various real world applications, including urban planning, environmental monitoring.
Mm-hmm. Mm-hmm.
But a significant focus or a portion of my research is dedicated into the integration of 3D geodata into urban energy modeling and simulation.
Mm-hmm.
And that was also one of the core research interests of Professor Coates and his research group at that point of time when I joined.
Yeah.
And the overarching goal is basically to contribute to the development of smarter, more efficient, and sustainable urban environments.
Yeah. 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 And I quickly browsed a bit some of your last papers that you were working on. That seems to have basically been since 2018, 2019, been your track ever since.
Right. Yes. As I said, when I came into research, it was pushing these boundaries beyond mere
Mm-hmm.
data visualization
Mm-hmm.
using this 3D geodata. So throughout my research career, it's all about making this 3D geodata more interactive, actionable for decision makers so they can use to address urban challenges. That's always my motivation to help tackle real world problems and advance our understanding on how to, I would say, build and manage better urban spaces.
What would you say in the line of your research and your work at the moment since then? What's the difference in you coming at these topics versus what an urban planner per se would do? In the sense of, are you more, because you mentioned like 3D simulations, for example, on particular matter noise modeling, wind analysis, or things like that, like on the,
Mhm.
or what's the difference coming from the planning of city to your angle that you're bringing in?
Yes, I would say what I am bringing is more decision making process through data. So what we call is data driven decision making process. It's more about
Mm-hmm.
creating this digital data so that the urban planners can make use of it to make more target based interventions, I would say. And the things which a normal urban planner will miss, which a really nice composed 3D city model or an urban digital twin can help urban planners to actually visualize and identify the problems which they are tackling.
So could you say that it's going, or maybe give us first some examples of which types of data that is, and in which formats those are handed over to urban planners?
Okay, so basically in our research group, we use the standardized 3D city models in format or in data model of CityGML, which comes from the Open
Mm-hmm.
Geospatial Consortium. And one key research topic, and this topic has always been a matter of great discussion within our group, is how to make this technologies, this 3D data, more easy
Yeah,
or more accessible so that even non-experts like urban
yeah.
planners can make use of it, because they are not going to sit down and make these simulations. Their probably work would be to take the end results of simulation into their urban planning process. So that's how our research is usually driven, that we basically our input data sets are in this formats of CityGML or various other geospatial formats. And then we try to simulate, of course, and then generate some key performance index, which then we integrate back into this 3D city models so that the urban planners can visualize it. They can make use of the KPIs which we have found from the simulations and involve it in their urban planning process. And most importantly, the idea is to make this urban digital twin platform more interactive and more as a stakeholder engagement tool so that they can actually use it as a platform to engage with their stakeholders or citizens into this public
Mm-hmm.
participatory urban planning process. Yeah, so that's how our vision is within our group of on using this
Yeah,
3D
yeah, yeah.
geodata.
So just maybe to try and formulate if I understood the aspects correctly. So CityGML as a standard that is basically the container for the 3D city data for the digital twin. Now that's basically, you could say that is a data format or a data container. So that typically would then, in a collaboration between multiple entities or stakeholders, that would be hosted on a server where the data is accessible, right? So that's like a geodata server, which independent of the technology or platform. Now, you guys are working on the interface between scientific simulation tools and kind of modeling problems and interfacing directly on kind of as natively as possible with this geodata. But then on the other side, the urban planners would also have a link to their tools where they can do a design. Then they have kind of this link to this data platform based on a clear specification of an exchange format where data needs to be translated from, I don't know, whichever tool. I'll get back to this in a minute, to then read and write to this geodata container so that whenever they are doing multiple design iterations, they can also then basically trigger another update of the simulation that is run either on server or somewhere else in your on a supercomputer or whatever, right? Now, one of the questions is that what are the typical software tools, planning tools that the urban planners are using? Because, and I'm mentioning this, is not all of the urban planners, for example, are very used to working directly with GIS data, with georeferenced data sets. So they are using more,
right,
you could say sometimes CAD tools that don't really have like proper georeferenced data that they are working with. That's the classical conundrum between the two worlds of the switching Cartesian system and like a proper geographic projections and so on. So what would be one or two, I don't know, design tools that you see commonly being used in your collaborations?
That's a very good question. So basically, my very first experience, I would say, with a proper urban planning tool, which was a CAD-based Rhinoceros. Again, there's a common problem of working in two different coordinate systems. And that was, let's say, my really very first experience on how the urban planners create their data sets and use it in there, and how we from 3D GIS or 3D Geoinformation, we see our data sets. And therein, then we developed some interfaces so that the Rhinoceros models can be georeferenced. We used some tools like FME or Feature Manipulation Engine to translate this Rhino models from their local coordinate system to more of our geographic coordinate system. And then once they were on the correct geolocation, we then translated it, or we converted it back to the city GML format, because that is more of a standardized way of, or as you mentioned, a standardized container for storing 3D city models. And then we used it for the simulation. Basically, that's our vision of, let's say, this urban digital twin framework, or what we are basically developing here, that not all the tools out in the industry will be, let's say, one-to-one compatible with our CityGML or the geoinformation or geodata formats, what we use. We will always need to develop such interfaces. But that is where this entire concept of, I would say, standardization and developing this interfaces based on the standardization and interoperability, that things comes into the picture.
We'll talk a little bit about standardization more afterwards, but that obviously makes a lot of sense. Cool. But before deviating too deep into the technicalities, so chronologically, to go back to your career, so you started working in Stuttgart at the University of Applied Sciences, but now there's also this collaboration or this project going on with the CERC, the Next Generation Cities at Concordia University in Montreal, Canada, where you're working on your PhD at the moment also. It's not yet fully finished, right? But ongoing and soon to be done. So how did this manifest, or how did this realize or get into kind of action to have this link between Stuttgart and Canada? Maybe you can explore also this side a little bit of your current career.
Right. So, yeah, exactly. So, I'm currently a doctoral candidate at Concordia University. So, it's a part of a cooperative agreement between Stuttgart University of Applied Sciences and Concordia University. So, there at Canada, basically, I'm part of the Next Generation Cities Institute, which is led by Professor Dr. Ursula Eicher, who
Mhm.
is also my primary supervisor alongside Dr. Koors as my secondary supervisor. So basically, Professor Eicher, she is at the moment Canada Excellence Research Chair in Smart, Sustainable and Resilient Cities and Communities. And before joining Concordia, she was head of the Institute of Applied Research at Stuttgart University of Applied Sciences. So
Mm.
that's how this link
Mhm.
comes. And
Mhm.
for over 15 years, she was at Stuttgart University of Applied Science, and that's how I know her. And yeah, with her, we have very impressive background and leadership. She guides her team's work on, I would say, enhancing building efficiency, integrating renewable energies, or developing sustainable urban solutions using advanced data and modeling platforms. So that is kind of a common thread that links both the universities, me, and the research group. Yeah, so that's where I am like kind of splitting time between both the universities. Yeah,
So you're
so
traveling back and forth.
yeah, so not regularly, but at least I make sure to visit Concordia once a year
Mhm.
for a month or a couple of months. Yeah, and then I come back to Germany because that's where I live. Yeah.
Nice, very, very nice. Let's explore this topic also a little bit more of traveling. So, I mean, you're originally you're from India. You moved on to Dubai, sorry, Sharjah, which is in the UAE. Then you moved on to Stuttgart, now Canada. So
Yeah.
you've seen quite a lot of countries meanwhile and a lot of cultures. And I wanted to also address this. Do you see a difference between the cultures that you've seen so far or in which you have lived on how technology in general, especially obviously geospatial technologies, are influencing society in the sense of how they are perceived by the different cultures and how open they are to them, how much potential they see, or if they are maybe potentially even afraid of certain aspects. Like one of the aspects that I see more and more, for example, is in the IoT, like the Internet of Things. The primary example that the for example, your fridge is telling you, "Hey, your fridge is empty. Please fill me,
Yeah.
and please don't just buy sweets and Coke. Buy also healthy stuff, right?" And some people now together, especially in this upcoming AI race or world that has this AI race in it, people or together also with the AI pins and the friend kind of these friend devices and so on, the new technologies that are coming out, people are getting a little bit more hesitant with privacy topics. Not to go too deep into these things, I'm just curious on how do you see different cultures interacting with geospatial technologies?
Absolutely. So, having lived in Europe, in India, and UAE, yeah, I haven't predominantly lived in Canada, but at least I've noticed some really
Mhm.
fascinating differences in how each region approaches technology and its
Mhm.
impact on the society. For example, in Europe, data privacy, as you said, it's a huge deal.
Yeah.
With strict regulations like GDPR, people are very cautious, I would say, about how their data is used, how their data is shared. The focus, I guess, in Europe is more on balancing innovation with very strong
Mhm.
privacy protection tools and frameworks and policies in place. And this sometimes means a slower pace of tech adoption.
Yeah.
But I think it's also all about ensuring ethical standards, that the data which we are sharing are not misused. And even though sometimes, as I said, it means a slower pace on adopting this technology, but yeah, at the same point of time, you're ensuring your standards, your ethical standards. In India, I would say technology is more of a double-edged sword, I would say, considering the huge amount of population we have. And so on one hand, it's a powerful tool for mobilizing people and driving change.
Hmm. Hmm.
On the other end, of course, there are a lot of challenges related to the infrastructure and access.
Yeah.
And data privacy regulations are actually still evolving. And there's a constant balancing act between a very rapidly growing technological field and the
Hmm.
regulatory framework. So there are, at times, we see a lot of clash, but I would say the current government is doing quite well in maintaining that balance between the pace at which the technology is growing in India and at the same point of time, the frameworks or the ethical frameworks, the regulatory frameworks, which needs to be developed. In contrast, in the United Arab Emirates, in UAE, the technology, I would say, is a key part of government strategy, especially, I would say, with the smart
Hmm.
city initiatives. And the focus is more on using technology to enhance public services and streamline governance. I would say it's more of a top down approach where technology is integrated, I would say, into the fabric of the entire urban development of the UAE. But however, I mean, I would like to point out as a common thread with all these three regions, they're all looking at geospatial technology to help with urban sustainability concerns,
Hmm.
climate change,
Hmm.
energy efficiency, and creating more
Hmm.
greener and livable cities. Advanced tools like 3D geospatial models are basically now transforming how urban planning across all the regions. They are more evolving at a faster pace, while maybe other locations at a slower, but it's at a steady pace. So yeah, it's all slowly but coming together.
Yeah, yeah, yeah. I've been interacting also with people, obviously, in the past, a couple of projects from the UAE, for example, or the Middle East in general. But also, I've been in contact with a couple of people that are working in geospatial and city planning also in India. And they are also addressing that, or what they mentioned is that, so there's in every culture in general, and they also confirmed it, for example, in India, in urban planning, there are certain things where, for example, the enforcing of zoning laws or protecting what things can be built where, there's not enough power. Maybe on the legal side, things are clear, but on the executive from the government to actually enforcing the laws, that is something that is weak or weakened in a lot of regions, so that this can also be exploited, right? And there are some of these, let's say, or every region has their own advantages and disadvantages. But I would definitely say also I agree on that. From the tendencies that I've seen, that the people that I interacted with, they are kind of pushing into a quote unquote better direction. But if you're looking at, for example, the differences between the United States or in general in America, urban planning versus European urban planning, there are, for example, there's the historic context. That is, you have centuries old buildings in Europe, and maybe the oldest building in the United States is maybe, I don't know, 100 years old or
Yeah.
so, and that's ancient, right? But there's also kind of how do you interact with the local fabric, and how strong is the government actually, or how strongly does the government want to interfere with processes and enforce some of those things? All of these issues not necessarily influence the technology, but how technology is used to solve the local problems. And I think that is very, very fascinating.
Yeah, absolutely. I mean, for example, as I said, in UAE, it's more of a top-down approach. So it's
Yeah,
like
yeah,
the government there, they are driving the way how a technology should be implemented,
yeah.
as compared to the Western countries, where it is more of research organizations, some standardized bodies which come together and they derive this blueprint on how they want to implement their technology. So, of course, there's a huge difference between each nations on how they implement their technologies. But if we look at a very broader or a very higher perspective, at least I won't be wrong to say that all of them, they are coming to this common platform of leveraging these technologies for the benefit of the society.
Mhm. Mhm.
And
Mhm.
I think that is more important, particularly now, because compared probably to 10 years ago or 15 years ago, the technology has advanced drastically.
Mhm. Mhm.
And now, when we talk about things like I think the way governments see implementing this AI driven technologies would be really fascinating, because this is something which is quite open right now. It's just coming on. There are no regulatory
Hmm.
bodies. And yeah, so it would be quite fascinating to see how these different countries, they try to draft these guidelines on implementing such technologies, which actually has a possibility to interfere in people's life.
Yeah, I absolutely agree. And not only in the context of AI and multiple governments and local cultural contexts of how to tackle things in this field, what would you say are, or in your research, what are important factors that are also emerging that people nowadays should be aware of, in the sense of, in globalization and in cultures kind of opening up more and kind of cities growing a lot larger into, you could say, mega cities where there are a lot of people and a lot of cultures kind of intermingling, and you could almost say that there are like global communities arising that are beyond the borders of countries, that come from completely different cultural backgrounds. Also, we've seen this after the pandemic with remote work and so on. So there are international teams now. In this context, do you see factors emerging in city planning, in geospatial understanding, in a cultural context, to be aware of those topics?
Yes, I mean, I definitely see this. For example, let's say there are quite a few applications like which has already made an impact,
Mhm.
quite a few geospatial technology driven applications which have already made an impact on the society. For example, if in my opinion, from navigating our cities and managing natural resources to improve public health, agriculture, I guess geospatial technologies have deeply embedded in our lives. And then they provide the data and insights, I would say, which are needed to address complex challenges and enhance basically the way we understand the world. Of course, people, the citizens, they still often lack the awareness of how they don't realize how the geospatial technology is already embedded in their lives. For example, the navigation maps like Google Maps we use, or the environmental monitoring apps. Even, for example, each country, they have this geospatial technologies basically which involve in using openly available data sets and tools
Mhm.
for
Mhm. Mhm.
tackling a lot of disaster management or disaster related issues. So these resources, they provide crucial satellite data, I would say, for tracking environmental changes. Yeah, I would say probably in disaster management and in navigation purpose, the geospatial technology is kind of an indispensable right now. And for instance, during events like floods or hurricanes or wildlife, they often offer this real time imagery and analysis. And that actually helps the first responders take informed decisions and coordinate relief efforts. And at the same point of time, of course, then there is the issue of accessibility
Mhm.
and cost, I would say. With some geospatial tools which are freely available, there are more advanced application and detailed data sets, often which comes with a price tag. And this can be a barrier for broader adoption of this technology. And again, coming back to the data privacy concerns,
Yeah.
which plays a major role. So basically, geospatial technology, it involves collecting and analyzing a lot of location data, which raises questions about how this information is used and shared. Yeah, so some people are, I would say, understandably cautious about their privacy and may be hesitant to embrace this technology completely. But at the same point of time, I think in last decade, the world collectively has seen how geospatial technologies can be helpful, particularly in time of COVID,
Yeah.
where
Yeah.
they played a crucial role in managing the crisis and supporting public health efforts.
Yeah. 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 For the people that are listening to the podcast, just because the examples you just gave, they're very good for people that are not aware yet of so many geospatial or applications of geospatial technologies. And while you were just mentioning a couple, I just had two particular ones that really had let's say an impact on me on kind of how far technology can go and what an impact it can have. And just two examples that just came to my mind again. So the first one is that we were in a prototype a couple of years ago for creating kind of 3D management tool for refugee sites. And we were working there with a company that actually owns their own satellite. And what they're doing is they're basically providing services for selling satellite pictures on a daily or on a weekly basis. That's their business model. They just say where you are, and then you just can get a contract of getting satellite pictures with I think the resolution was something like 25 centimeters per pixel or something like that. So that translating to a resolution of the image seen from the satellite that translates into 1 pixel actually corresponds on the physical surface where you're standing to about 25 centimeters. So that's very accurate. And so the first application that where these images are used as an example is for refugee camp planning, like literally managing the process of these huge areas, for example, in southern Iraq, where there are literally about, let's say there are these temporary cities, or that used to be temporary cities, for example, that are now fully fledged cities where about 100,000 plus people are living. They used to be a refugee site or refugee camp, and now it's basically a functioning city that will not go away. And they are so large geographically that they are using satellite images to manage this. I mean, this had when I heard about this in that project, that had a big impact on me, because it's tough, right? It's really tough. And the second one, the second example that just came to my mind, which I just find is absolutely a fantastic use of these technologies, is that in Australia there are these wildfires. And so because they wanted to kind of try at least to predict where the wildfires could appear, so what they did is they basically mapped the regions that are most prone to wildfires that can occur naturally, right? And then they modeled the terrain, they modeled and mapped which type of materials there are. And then also through the use of satellite images, they actually started to measure the temperatures from space in those locations. And then they developed, so basically they said, where are the heat points? And they are feeding this data constantly into this scientific simulation model that then takes the temperature, the wind directions, the heat, and tries to predict where there's the biggest likelihood of where a fire could occur, and then also compute where would it spread to, so that in high-risk areas, they could even go in and log certain, or logging in the sense of cutting certain trees down to create barriers where the fire cannot continue to spread. And they could do that even before a wildfire would potentially start. Wow. And so that's such a fantastic use of technology that is not very widely used. So just not to go too deep into these things, but just as an additional examples for the audience.
Yeah, in fact, I have a couple of such examples as well to share.
Mm-hmm. Sure.
I think that was, I would say the trigger, this first example was when I was doing my master's. We had a small summer school, I would say, but it was kind of a real life scenario where we had to work with. We were working on a coastal area, which is always prone to floods, heavy flood zone. And I think that was if I remember correctly, that was the very first time where I used 3D models of a buildings, not that highly, no, very high resolution data,
Mm-hmm.
but was just simple footprints with build extruded to its correct height. And we did some flood simulation using data sets like the digital terrain model, the digital surface model, the trees. And then I think one crucial output here was that what would happen if I construct a barrier just in front of some houses which are very like the first flood hit buildings.
Mm-hmm. Mm-hmm. Mm-hmm.
And there, that was actually kind of a fascinating experience because it was me who was doing all this modeling. And then the local municipality, we were doing the study in a place in a state called Kerala on towards the coastal side. And the local municipality there, they actually used the application which I developed in reality. And they, I don't know, but it in some of the reports I read, they used when actually the floods hit the area, they were able to evacuate a lot of people from there. And then I think way after in one of the news report, I read that they used some 3D geospatial technologies to do that, and I was quite happy to see that. I don't know if it was my work or somebody else's work, but it actually I was quite happy to see that it made real life impact from the
Yeah.
work that, yeah, which I showed or I explained them.
You're a hero, my man.
No, I even don't know if it was my work or not, but it was just, yeah, it was something which I would say put me on the track of this entire 3D
Yeah.
geoinformation
Yeah.
thing. Yeah.
Yeah. Yeah. Talk about real world impact.
Yeah. Yeah.
Yeah.
Yeah.
Beautiful. So, kind of about your work in general, what would you say at the moment, or maybe for now or in the future? Does it have more of an impact on kind of professionals and city planners and politicians for tooling and processing, or is it potentially also kind of going beyond that in also changing a little bit the status quo of directly the citizens? I mean, there, if you interact with or if you provide tools for city planners and the authorities, for example, sure, you will have an indirect application for to citizens or the average kind of person living in a region or in a city. But where would you say do you have most impact at the moment? And is that good, or would you like to shift eventually to also kind of, let's say, reach more people with other tangents that you see to your career and your work?
I would say at the moment, because most of my work is more into research, I would say it touches more of professionals, planners, maybe policymakers and the tools they use. I would say a very good example would be during this COVID time. So in Germany, it's a well-established process that whenever there is a new urban development, the organization or the company who is responsible to do this urban, they must have a public participation process. They must involve the citizens, and there must be a healthy exchange of dialogues between what the citizens want and what they want to plan. But during the COVID, this in-person meeting, which is actually a traditional way of conducting such public participation events, that was quite not possible. So I would say that was a time where we saw how technologies like geospatial technologies or urban digital twins, they can be fully exploited, because during that time it's just you open. So we managed to create this entire digital twin of the existing scenario and the new scenario, which or the, let's say, the remodeled or the redeveloped scenario. And then we allow the citizens to go on the website right from their home and interact with the application, put their comments, engage in some questionnaires. So it was more of completely changing the way how citizens engage with the local municipalities or with the practitioners or urban developers who are in charge of developing their neighborhood. So I would say that was a very nice experience for us to really see how research, what we actually do inside universities, write some papers, they actually transform into a real reality, into real applications, and how citizens can actually make use of it. we were also able to collect some feedbacks from the citizens based on different age groups. And there were some really nice insights. For example, even the older people, like above 65 plus age, even they were able to engage with
Mm-hmm.
such tools,
Mm-hmm.
provided you have good enough guidelines for them to make it easily accessible, to make it easily understandable. And I think that is the whole idea, or I would say one of the key aspect of having an urban digital twin, or having this geospatial technologies, to not only impact professional planners but also to
Yeah.
engage citizens. And I think with the growth of geospatial technology, I think this gap between the citizens and the practitioners or the public authorities will be more thinner than ever
Yeah.
before.
Yeah. 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 Nice. And obviously, kind of deviating a little bit into the standards, they will also help. So let's go a little bit into the direction of standards. We mentioned CityGML, which is, you could say, more of a technical standard. There's also this OGC that you briefly mentioned it before, but I would like to let you explain a little bit kind of this field of what types of standards are there. Maybe give us a tiny little bit of an influence and how these types of different standards actually interface with different entities in politics and the industry, and obviously also, for example, citizens and people that want to, for example, participate in planning processes and public participation, things like that.
Right. So I think standards in geospatial technology are crucial for ensuring that data and systems, they work seamlessly across different platforms and organizations. As we had this topic on urban planners dealing with their set of data sets, and the domain of GIS specialists or geoinformation people dealing with their set of data sets. So I think standards are really important to ensure that the data can be easily exchanged
Mhm.
between multiple domains. They are basically, in a simple way, I would say standards are essentially agreed upon guidelines that ensures consistency and interoperability in geospatial data and technologies. For example, the Open Geospatial Consortium. So basically, it's an international organization. It's a volunteer-based organization, and they develop international standards which enable geospatial systems to work together. And these standards covers a range of technologies from web APIs like the Web Map Service, which is used yeah, since long, I
Mhm.
would say,
Mhm.
very long, to city information models such as CityGML, to different spatial data infrastructure modules. So they help ensure that these different systems, whether from different tech providers or across different domain experts or even across different countries, they can exchange and interpret geospatial data consistently. And such standards, they basically, I would say, help governments and regulatory bodies by providing a common framework
Mhm.
for data sharing. I think that is very critical for developing countries' geospatial infrastructure so that it can have a better collaboration across different
Mhm.
departments and take more of informed decisions when it comes to managing urban environment and human settlements. Yeah, for businesses, for example, a city planning firm might use standardized geospatial data to create detailed maps and models that probably will align with those used by local authorities or utility companies. So, standard makes it easier for organizations to share data without compatibility issues and to make the implementation more effective and scalable for the future.
Just a quick question in between for those processes. Should these and those standards, should they be, in your opinion, or maybe what are the pros and cons? Should they be open source slash closed source slash non-commercial, or kind of open data in the sense of that everybody owns them and it's not kind of a black box that could potentially be in the sense of monetized or used for certain negative things, in the sense of that certain people or entities could just exploit certain standards for their own use? What's your opinion on this? And so, for example, because this goes in the direction of who would finance these standards like the OGC, right? It needs to money to develop them, to finance them. And wherever there's money involved, there's a little bit of hypocrisy also going on, right?
Yeah, definitely. I mean, I would say it should be a blend of open standards and commercial or closed standards based on how sensitive the final data set or the final application would be. Not everything, of course, should be open because, I mean, in today's world, it is, I would say, much easier than before to misuse the data sets. However, I think there should be some guidelines which distinctly tell us that for these type of applications or for these type of use cases, these data models must be open, and for these type of applications, it must be closed. So such guidelines, I think, from the policymakers would really help in deciding on whether to keep a standard open or closed, irrespective of the whole economy thing and the whole monetary things. With that, I would also like to say that for people like us, for researchers, where we more focus on open data standards, again, it's quite important that we don't misuse the openness which is available. Otherwise, that could easily be misused. And then if it goes to a more of a closed source, it would be hard to achieve some further development.
Yes, I see. You don't want to put yourself in a straitjacket afterwards, or you want to make sure that it's future-proof, the whole solution that you're developing. Yeah. That absolutely makes sense. Yeah. Now, who enforces standards? So, I mean, we briefly talked about who defines them, but also who enforces them and who comes to your door, knocks on your door if you step over the guidelines. And if you say, well, I don't care about this standard, I'm going to do it my way. Who are the entities that you agree on playing with, and what are the rules that could be broken?
That's a very good question.
So I love breaking rules.
So I would say while standards themselves are not enforced in a traditional sense, it's more about their adoption is driven by their widespread acceptance and use. So it's not like somebody is coming to me and saying that, okay, you must use CityGML or you must use this standard or that standard. It's more about the widespread acceptance and the use. For example, CityGML as of now is used by many municipalities, many governments, many countries worldwide to distribute the 3D city models. Again, there is some restriction in terms of level of visual details. So basically, there's a concept in CityGML, there's a concept defined on how detailed a building or any other city object could be modeled. And most of the time, or you will usually find data sets until level of detail 2, which, for example, in terms of building or a building model, it means just a building extruded from its footprint with its correct height value and the correct roof geometry. So most of the time, the data sets, what you will find openly or freely are until level of detail 2, but more detailed you go, they are not available, either due to privacy concerns. So they might be available privately, or maybe such data sets are not made purposely so that people do not make wrong use of it. So I would say organizations and companies, they often follow these standards because it enables interoperability and compatibility, as I said, across different systems and platforms. Governments and regulatory bodies may mandate compliance with certain standards for public projects or data sharing, effectively enforcing their use. But I would say there must be such strict guidelines, right, coming from the government and regulatory bodies. On one hand, not to make the community feel that they are being enforced by the standards, but at the other end, to have this widespread acceptance, use of it, and to encourage to stick to the standards to ensure compatibility, reliability, and so that let's say the countries or the organizations, the entire geospatial infrastructure works smoothly. Yeah.
Yeah, I mean, in Germany, especially, I know from a couple of years back, like CityGML is actually something that is kind of integrated in political processes. So government, or not only Germany, but also in other locations where it's kind of a standard that is also kind of backed by law for certain processes. So this can happen, but it's not necessarily usually in the case in a lot of locations. But obviously it does make sense for standardization, also on the side of political processes.
Right.
Definitely.
Yeah.
How do these different standards influence or impact your work? Only positively, or do they also restrict you in the sense of that because you're kind of they're shackling your arms a little bit, that they prevent you from, let's say, proceeding further in they're more restrictive? How do you see these dynamics?
I think, at least for me, I feel that working with standards have actually improved or influenced more detailed analysis, or let's say, for example, simulations, what we do.
Mm-hmm.
For instance, let's say CityGML specifically with its semantic aspects,
Mm-hmm.
which are actually very vital for energy simulation, and no other standards, they actually give you the semantic detail, or no other standards allow you to model your building geometries with the semantics. And this standards basically helps to structure this 3D city model in a way that makes them usable for detailed energy analysis and simulations. And it ensures that the data about buildings, infrastructure, and energy systems, for example, is all organized in a consistent and interoperable format, enabling more accurate and meaningful simulations.
Mm-hmm.
And by using the standards, at least I can be sure that the data model I work with, they're all well structured, comprehensive. They improve the accuracy of the emission estimates. And most importantly, I can share my results, I can share my data to another system. So it's not like I'm restricted with just my own system. And I think that is very important moving forward, because you won't find a single tool doing all the work. It's always about creating that ecosystem that one tool can communicate with other set of tools.
Yeah. All right. Cool. Well, I would say we move on a little bit into the direction of 3D.
Yeah.
Also, because I mean, we've been talking about geospatial in general, but because this is the 3D Environment podcast, let's dive a little bit into the aspect of your work that have to do specifically with 3D. We've been talking about real-world application. Obviously, in 3D, there's so many different applications, but there's kind of the real-world, civil engineering, urban planning, storing geodata for all of these real-world planning and management applications. But there's also kind of the fictional 3D world, like, for example, the movies and the games. How do you see the differences and the parallels between them, and how far would you say do they influence each other positively?
Right. That's a fascinating topic, I would say. So, yeah, I mean, when comparing 3D work in the real world versus fiction, such as in movies and games, there are some, I would say, some striking differences and interesting parallels. So, for example, in the real world, 3D technology is used for practical applications, like you mentioned, like urban planning, civil engineering, infrastructure development. It focuses on creating, I would say, accurate data-driven models that help us solve real problems and make informed decisions. And these models are basically grounded in actual data and are used to address practical challenges. For instance, I would say in urban planning, we use 3D city models to simulate how new buildings will impact a city's skyline and infrastructure. On the other hand, in fiction, I would say whether it's movies, TV shows, or video games, 3D technology is often used to create immersive and imaginative worlds. And these environments are designed more for storytelling and visual impact than for practical applications. So in movies, you might see stunning 3D effects that bring fantastic world to life. in games, you see 3D graphics. So it's more about using this 3D technology to make interactive and engaging experiences that are, I would say, driven by narratives rather than real world data. However, I would say both real world and fictional 3D work share a foundation in visualizing complex data and scenarios. They both rely on advanced 3D modeling and rendering techniques to create detailed and convincing representations. And I think in both the domains, the goal is probably to communicate information effectively, whether for making critical decisions in terms of real world or emotional experience for the audience. So that's how I see the parallels and how they influence each other.
Yeah, I mean, especially over the last, let's say, 10 years, I've seen a huge impact of the real-time graphics on the game engine side of things that hugely influenced also this scientific visualization, especially not necessarily only, that was just an intermediate step in game engine frameworks for nice visualizations and communication of ideas and facts, but also I think they had especially a huge impact in web-based real-time visualization like WebGIS and using WebGL rendering technologies that just have to deal with limited bandwidth, with internet access, with accessing vast data sets like deferred loading and all of those things. Yeah, in general, kind of storytelling, whether you're communicating information that is highly scientific or narrative driven, there definitely are a lot of parallels.
Right.
But I mean, so far we see a lot of kind of the rendering engineering that influenced the fidelity of the visualization and access to 3D tools on the GIS or geotechnology side of things, or more planning and so on. Nevertheless, I also see some tendencies kind of coming from the other side. I mean, it's coming more and more that some of those technologies are now also used more and more for actual geographic tools are used for laying out game levels.
Right.
Or, for example, for, I don't know, let's say if your game is plays in a city where half of the city was burned down. Now you could use basically a fire simulation in a geographic data framework and just simulate it and then export the data and kind of where would the fire spread highly realistically and bring this over into your game narrative. So I think the link between tools that enables such fantastic like dialogues and people like you that are basically handlers of technology, programming the link between technology, you guys will have a very, very bright future ahead where you can actually switch also kind of between the fields. And that's something that was very, very fascinating to me for a long time. And also one of the motivations to start the ICE conference, where these things are specifically made aware also to a wider audience.
Right.
Yeah, but talking about advanced geoinformation technologies in 3D, maybe you can walk us a bit through some of the more complex problems you are dealing with, or for example, simulation tools were used using CFD, so computational fluid dynamics, or the transport of particular matter, and so on. So what are these topics and tools?
Yeah, I think from challenge-wise, I think first and foremost, the quality of data is absolutely crucial. Good data is the bedrock of any reliable analysis. And without it, even the most advanced tool can fall short. For instance, in urban energy simulation, what we do here, we use 3D city models to predict how buildings will perform in different energy scenarios. If the quality of building geometry that we use, if it has errors or artifacts, then it can lead to over or underestimation of many key variables, such as calculating building volumes, for example. Similarly, if data on building structures or energy usage is outdated or incorrect, the simulations won't reflect reality. And that can impact everything from energy efficiency planning to probably to infrastructure investments. So the quality of the data, the granularity of the data, I would say is another key challenge. For instance, traditional method in estimating carbon emissions often work at a regional or a country scale, which can mean, they miss local hotspots or emissions happening inside a neighborhood. And by using this detailed 3D city models, we aim to get a finer resolution down to individual buildings. But this requires accurate, high resolution data on everything from building materials to transportation patterns. So it's also about tackling this granularity challenge. And that is where at times simulations can help to close this gap or to fill in the gaps. Computational fluid dynamics, they are usually a very heavy computational models. And to use 3D models to study airflow and pollution dispersion, it actually adds another layer of complexity there, because these simulations then require precise data to model how pollutants move through the urban environments. And I think just coming back to that point of how the game engines and this real world 3D data influence each other, I think these are the models where you can actually see or imagine doing the CFD simulation in a very fictitious world, having this entire dispersion of air pollution or even the winds in a way more realistic manner than it happens right now. It's just another example on how this different technologies can even impact this 3D technology which is used in entertainment industry. Yeah, so I guess the challenges are quite there in terms of building geometries, terms of granularity. Also, I would say in terms of integrating data from various sources and ensuring that the models they accurately reflect complex urban processes. And this is where I would again say the standards play a major role, because if the standards are not developed, then this will make this data integration from various different data silos much more trickier than what it should be. Yeah, so data integration, granularity, I would say handling the sheer volume of data is another challenge. More data you integrate, more would be the volume of the data you produce. And this high resolution 3D models and simulations, they actually generate massive amount of data, which require, I would say, substantial computational resources first to process and analyze it effectively. This means not only having the right technology, but also efficient managing data storage and processing infrastructure. So I think overall, from ensuring data quality to managing integration and computational demands, these are some of the key hurdles probably we need to address to make our models more accurate and actionable as possible, even in the future.
Yeah. How do you see the future of gathering geographic data in the sense for more accurate statistical data over larger areas? You just mentioned before kind of that a lot of the data is at the moment just available at, let's say, at the country level, which doesn't contain some of the peaks that are important. How do you see in future that, for example, I don't know, autonomous agents like robots or drones could potentially help with large-scale assessment of, for example, certain things like, I don't know, tracking, I don't know, water bodies and, I don't know, the quality of them, or, for example, tracking industrial sites and taking photographs of what the smoke looks like and, I don't know, tracking or capturing, for example, terrain deformation after a volcanic eruption. There's myriads of different applications that could potentially just autonomously be, or where autonomous agents could potentially be used for large-scale data collection. How do you see this play out over the next, let's say, 10 to 15 years? Do you think this is feasible?
I think, in my opinion, the building blocks are already developed, I would say. They're already either developed or in process of being developed. Looking ahead to the next decade, I'm quite excited about where the things are heading. We are probably like to see how this autonomous robots, drones, they influence this entire data collection process, the data analysis process. I think together with drones and such advanced technology, even I can imagine the rise of more crowdsourced applications. We already know the most commonly used OpenStreetMap, but I more and more people are getting aware of using smarter technologies. They are now more exposed to smartphones, for example, as compared to 10 or 15 years ago.
Yeah.
So there's a huge tendency of how this autonomous robots, this advanced drones and all, they will impact the way the geospatial technology is at the moment. But I see crucial role which is played even by the residents, by the citizens on the way how high resolution data is being collected and then used for better analysis and estimating urban processes.
Yeah.
And I think we're also forgetting about immersive experience like the augmented and virtual reality. That is another whole domain which is coming up slowly and finding its interface with the urban development. So these technologies will probably become more prevalent, offering interactive 3D visualization that can actually enhance everything from city planning to navigation. And at the same time, I think AI will continue to play a bigger role, automating the analysis of data and leading to more proactive solutions in areas like digital management or disaster management and smart city planning. Yeah, and as we gather more detailed geospatial data, I think again ensuring data privacy and security will be more critical. So we can expect more advancement also in how we handle and protect this information.
Yeah. I definitely see also that AI could help with kind of the data crunching in the sense of making data sets compatible, which is a huge problem in geospatial information. That if you take, for example, tree cadastre data from two different cities, like 10 kilometers or 10 miles away from or apart from each other, they may have completely different attribution, granularity, and level of accuracy. So kind of to try and find a countrywide model that is harmonized, or even Europe or continent-wise that is harmonized. This type of process is so incredibly labor-intensive and so incredibly boring for human beings to do, which is a huge factor. Let's automate this stuff, right? Let's, yeah.
I mean, I remember I think quite a while back, I kind of forgot name of the professor, but she mentioned that most of the time we spend in data cleaning and making sure that the data is proper, reliable, and we spend less time in doing the actual work. So we then tend to automate this entire process of data cleaning. And I think that is probably, I would say, the future of geospatial technology, which we will see next coming decade. A lot of automation in data engineering side.
Yeah, I fully agree. It's a super fascinating topic. One topic where I also see that it's also kind of going in this direction. There was a fascination for me over a couple of years, and I would love to have a little bit more time to actually go in this field and explore it a bit more, is to detect landmines. It's a very, very sad topic. Obviously, landmines being explosives that are engineered not to be found, and you find them all over the planet, from still existing in Vietnam and in the Middle East wars, and now obviously in Russia and Ukraine. So I also see that AI with autonomous agents hopefully will be able to have a big impact there in being able to detect and resolve this situation, because that's another geospatial field, and there's zero money to be made in this, right? Which is absolutely saddening to see that because there's no money, it's very hard to progress in these fields.
I mean, I think just a few months ago, we had this news in Germany that they found this bomb from even World War II, which is it was right in the center of a neighborhood. And I think,
Yeah.
it's quite sad that there's, more or less zero funding or zero money
Yeah.
allocated for developing processes to identify landmines and such
Yeah.
things
Yeah.
from
Yeah.
defense purpose as well. Yeah.
Yeah. Yeah. No, absolutely. And that happens more than we would know really as a public person, because these things are not announced, but they happen very often all over the planet.
Yeah.
And yeah. But so when you're working in general on let's say scientific papers and scientific problems, how often is it the case where you would wish there were a specific software kind of designed specifically to address this task? And so kind of in this context, what would you say what is more difficult, describing the problem and finding the scientific model to describe the problem, or then kind of finding the tool or developing the tool that actually solves the problem? So in the sense of, because there's always kind of this chicken and egg.
Yeah.
How do you see this dynamic from an engineering point of view? How does this impact you?
Yeah, as you said, it's deciding whether describing the problem itself or writing the software part it's a bit like comparing apples and oranges. It's like both are challenging, but I would say in a different way. So describing the problem or developing a model can be incredibly complex. So it involves, let's say, understanding and defining the intricacies of the real world issues first, which we are trying to address. For example, when we do this urban energy simulation or carbon emission analysis, capturing the full scope of how different variables interact, like energy usage patterns, building materials, transportation systems, it's a huge task. The challenges lies in ensuring that the model accurately reflects the real world and can provide you with meaningful insights. And these things requires deep domain knowledge and careful consideration of how various factors impact each other. So, for example, for a geospatial expert, maybe this is not what he is expert in, but that is where this idea of working together, geospatial expert, a domain expert, a computer science guy, all coming together and then solving a real world problem. But on the other hand, writing the software to implement these models, it basically introduces its own set of complexities. Once the problem is defined, creating software that accurately simulates or analyzes it, it involves translating complex mathematical and physical principles into line of codes. And I would say this means dealing with programming challenges, ensuring the software can handle large data sets efficiently, and integrating various data sources. The software also needs to be robust, user friendly, and capable of producing accurate results. In all, defining the problem is complex because it requires a deep understanding of the real world issue.
Yep.
While writing the software is challenging due to the technical demands of implementing the model effectively. So both aspects are crucial, interdependent, and I think tackling them together will ultimately lead to successful outcome in, at least in scientific research projects.
Yeah, I like to compare apples with oranges just to confuse people, right? But it's part of the exercise. I don't want you to fall asleep. No, no, but I mean, obviously, I'm phrasing these things potentially sometimes a little bit naive, and sure, they do depend on each other. But I just want to also uncover, also for the audience, some of the challenges, right? That I want people to inspire to think, or I want to inspire people to seeing deeper into the complexities, which may lead them to do further research on their own to see, okay, yeah, this is actually much more complicated than I anticipated. And okay, now I see that this is the stuff that you have to deal with, for example, when you're doing a PhD, right? So I find it fascinating to kind of dig deeper and try to specifically analyze what are the challenges in that and what would it entail to describe a scientific problem? Like, how is there a formula for solving climate change? I think that's one of the topics that we're all quite aware of, that it's super difficult. And yeah, I would say it's really, really, really hard to consider all of the factors. But I think that the discourse about it is, and what is the granularity of the problem that you think you can handle, and being aware of the different shoe sizes of problems, right, and how you fit in the cogwheel of society and the processes and so on. I think that's really, really important as a reflection on what you're doing, where you want to go with your career and life. And I mean, especially also in geospatial technology, that would be kind of a next step into which I want to kind of segue, is that there are more and more these, let's say, software component platforms as such. For example, the Esri ArcGIS platform that has like hundreds and hundreds of little tools that you can just pick and combine. It's like they're modular, pretty much everything is compatible to each other. And with more and more robust platforms like that, it may actually also become easier to model and develop like both sides, both on the software engineering side, but also on the tackling a problem by leaving the opportunity open to add more details later on, so that it's kind of, you start smaller and you start going into bigger and bigger complexity. You can expand, also define milestones over a couple of years without actually needing to write your own complete software from scratch that solves this one problem, which you may not be able to find funds for. So how does this influence your work? And would you say over the last couple of years this got better, or technology got more accessible in that sense?
Yeah, I would definitely say the technology got more accessible. I would say more generic modular softwares like ArcGIS, it offers huge amount of flexibility and a wide range of tools that can be tailored to various tasks within a single system. And I would say this is a great way for general applications where one platform can handle data analysis, mapping, 3D modeling. I would definitely see more of such tools being developed going forward into the future. But at the same point of time, I also see more localized or specialized implementations, which are becoming increasingly important. And most of the time, you see it as an open tool, as a free tool, either as an open source or as a free tool. And the local, geographic, political, and legal constraints, at times, not always, but at times, they often require tailored solutions that a generic platform might not fully address. For example, let's say different countries have unique regulation or data privacy, and urban planning needs can vary widely. So specialized tools can address these unique requirements more effectively than, in my opinion, a one-size-fits-all platform. But I think what is more important here as well is where the exchange of data or data interoperability becomes crucial. Ideally, modular platforms, they should be designed with strong interoperability standards, allowing them to, let's say, seamlessly integrate with specialized tools and local systems. I think that is more or less the same as concept of having this geographic coordinate system, a projected coordinate system, or a very localized coordinate system. So, and where this data interoperability becoming more critical, this means that while we might have a core platform for general tasks, which should be able to work well with applications that can handle local constraints or provide specialized functionalities. So I think probably in the future will likely involve a mix of versatile platforms and targeted solutions, all interconnected through these geospatial standards to meet both broad and localized geospatial challenges effectively.
Looking back to the last 10 years and predicting where we will be in the next 10 years, kind of technology-wise, what do you see is possible now that wasn't possible 10 years ago? And where do you see we could be in 10 years?
Yeah, I mean, over the past decade, I would say the evolution of geospatial and in particular the 3D geospatial technology has, I would say, nothing short of remarkable. 10 years ago, when I was doing my master's, collecting high resolution 3D data was itself a very daunting task. It often required very pricey equipment and was limited by the technology of that time. But fast forward today, it's like the game has changed entirely. So advances in drones, LiDAR, satellite tech, now even our iPhones, now they also come with
the LiDAR scanner.
LiDAR scanners.
Yeah.
This such technologies have made it possible to capture incredibly detailed 3D data more easily, more affordably than ever before. This means that we are now able to create high, precise models of cities and buildings with incredible detail. Another aspect, the real-time processing, is something which has taken a major leap forward. What used to be slow and cumbersome is now fast and efficient, allowing for real-time simulation and analysis. Integration, data exchange have also seen huge improvements thanks to such open standards and APIs, where combining different types of geospatial data has become much more smoother. This means that we can integrate various data sources into single cohesive analysis, which is crucial for comprehensive planning and decision making. It's like now I think it's time that we move on from just a data silo approach, which used to happen until now, to more of a ecosystem or more of a cohesive planning and analysis approach. And I think a decade ago, we didn't had that enough technology to think in this direction, I would say. I think in general, working with 3D geospatial data, which was pretty complex and I guess required some specialized skills nowadays with technologies like ArcGIS, it has become much more easy creating this geospatial applications. It's become much more user friendly. There's lesser and lesser amount of time which one would invest in development or writing lines of codes as compared to the previous technologies where even to even to make simple web applications, we had to write a lot of line of codes. So nowadays user-friendly tools and platforms have made it much easier for people. And of course, now with ChatGPT, even those without a technical background, it's just you need to know the correct prompt and you have your answers in front of your screen. So a lot has changed, I guess, since last 10 years or 15 years. Yeah, and I guess looking ahead to the next decade, we would probably see more urban digital twins becoming more advanced, integrated with all real-time data, which are coming from AI or autonomous robots, drones, UAVs. I think this could revolutionize how we manage cities, optimizing everything from traffic to urban spaces to energy use. And as we move towards gathering more detailed geospatial data, we can expect more reliable, more accurate, and more granular analysis, which can fuel the decision-making process.
It all sounds so positive. It's you're giving me a lot of hope that by your experiences, by seeing the technological uses, by having a positive impact. I've had podcast episode where I was a little bit more, let's say, negative sometimes in the sense of I don't see a lot of hope, but you're doing a fantastic job in saying, yeah, it's going in a good direction. It's not all is bad, but it's going to be good.
Yes, but as I mentioned previously, we must ensure about the data privacy and security. And
Of course, yeah,
more the technology advances, I would be not wrong to say there will be more people to misuse it. More
yeah.
the easier it gets, more. I don't want to be negative here, but I think from the past geopolitical situations, it won't be wrong to say that advanced technologies can actually be a downside for, or a drawback, or a big negative for us, for humans, for human
Yeah,
race
yeah,
in all, I
yeah,
would say.
yeah,
Yeah.
yeah, yeah. I mean, there's this famous, I mean, it's kind of a really bad analogy, but there's this saying that guns don't kill people,
Yes.
people kill people,
Yes.
right?
Yes.
And so it's a really weak sentence, but it's kind of technology in itself is not
Yeah.
bad because it's just a tool. It's about how it gets used, and that basically boils down to the human
Yeah.
condition, to where we want to go as a society,
Yeah.
as a species, together, all humanity together with the planet, with all of the animals.
Yeah.
But nevertheless, you're giving
Yeah.
me a lot of hope.
Yeah, I mean, I guess my this entire perception is probably a bit influenced by movies like Geostorm, which I would say it's a perfect example for the topic what we're discussing at the moment.
Yeah, yeah,
Technology can be a boon. At the same point of time, if it falls in wrong hands, it can be a disaster for the entire human society, human
yeah,
race.
yeah,
Yeah.
yeah, 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 yeah. No, that makes sense. All right. Let's talk a little bit about you. Tell us about Rushi.
Ooh.
What are your hobbies? How do you spend your time next to just indulging in technology and all of those work related things? I mean, you mentioned you're a big foodie
Yeah.
at the beginning.
Yes.
You made this very obvious. So tell us a little bit more about you and the private side of you.
Well, let's say when I'm not doing all this 3D geospatial urban digital twin stuff, I'm as I said, I'm a huge foodie, so I spend a fair amount of time experimenting with new recipes.
Mm-hmm.
Again, I would say thanks to COVID, I didn't knew how to cook, but in COVID time,
Mm-hmm.
I had to cook. There was no other option, and that
Mm-hmm.
actually inspired me to my new hobby of
Mm-hmm.
experimenting with a lot of new recipes, or even hunting down, let's say, hidden gems in my neighborhood for the local cuisines.
Mm-hmm.
Apart from
Mm-hmm.
that, I'm also a bit of tech geek, so I often find myself playing around with latest gadgets or indulging in a new computer game maybe in my free time. I'm a huge fan of Manchester United Football Club. It has actually a deep impact on my life and beliefs. So that is kind of
Mm-hmm.
yeah, it's something which is engraved in my life, I would say. Yeah.
Did you go to a match, or what? Where does this come from? Did you have this already as a kid, or is this something you developed over the last years? How did this manifest?
Yeah, I still dream of going to a match, but this was all from my younger days. We
Mm-hmm.
used to watch on televisions,
Mm-hmm.
so that's how it all started. But I would say it's more about the way that football club is, the history of that football club,
Mm-hmm.
some
Mm-hmm.
great
Mm-hmm.
managers, past managers, yeah, and the teachings or the way they used to handle the club,
Yeah.
the leadership skills which they used to show. So that has got some deep impact on the life and on the beliefs of my life, on how I see my life in terms of whenever the chips are down, how do
Mm-hmm.
you come back? So it's more about I'm a fan of that football club, but more importantly, I'm more a fan of the thinking, the belief of one of the legendary managers, Sir Alex Ferguson. Yeah,
Yeah.
so that has a big role in formulating some of the beliefs in my life. Apart from that, traveling is another big part of my life. I love catching up with family and friends. So I at least make sure to visit my family in India once a year. With friends, if not in person, then always through video calls. It's always nice to stay in touch with them. In fact, these days I'm also hooked on Netflix, so exploring
I
some really nice sci-fi series. So right now I'm going through this three body problem. It's
I heard very
fascinating.
good
Wow.
things. Yeah, yeah,
Yeah,
yeah,
or
yeah.
just catching up some classic films. So it's perfect way, I think, to take a break from this complex world of 3D and geospatial data and to just enjoy some
Can
downtown.
can
Yeah,
relate.
with family. Yeah,
Very, very cool. But regarding Manchester, it's a really cool city. It has this kind of industrial, grungy
yeah.
vibe. I've been there a couple of times because I used to work a little bit further up a couple of years ago. And I used to go out in Manchester a couple of times, and it's a fantastic
Wow.
city. Also, I can highly recommend to go to it. It has very different vibe than London, for
Yeah,
example. It's
yeah.
a bit more, yeah,
Right.
grimy,
Yeah, yeah,
industrially kind of. I love it. I really love
yeah.
it.
I think the culture there of seeing this industrial or hardworking people and then making it to the big
Yes,
stages.
yes, yeah,
Yeah, that is one point where I relate myself with my background.
yeah,
And also when I hear the stories of, let's say, old Manchester United teams of the past, the way these hardworking people they've came and formulated this club. So that's
mhm,
where I draw a
mhm,
lot of inspiration. Yeah.
mhm,
So yeah,
mhm.
it's a dream, and I hopefully once in my life I get a chance to visit Manchester. Yeah.
Yeah, you should. You definitely should.
Yeah.
Plan a
Yeah.
weekend. Plan a
Yeah.
weekend.
Yeah.
Just go there. It's not that far
Yeah. Yeah.
away.
It's not. Yeah. Let's see.
If you don't do it, I will personally come pick you up and drag your ass over there.
Ah, it would be nice also to spend
That's
time with you and yeah, interact with all the things going around professionally and personally as well. Yeah,
yeah, I definitely see that this is an option because I also know I should take more time
yeah,
off,
yeah.
but that's another
Yes.
story there. Well, how do you see your future in a kind of next couple of years? Do you see yourself mostly in kind of in academia, or do you see that potentially you could also go a little bit more back into the industry, maybe a little bit of both? How do you see this planning out or panning out?
Mm, I see my future a little bit of both, I would say, blend of both academia and industry. So, I mean, academia, it offers this chance to, dive deep into research, push the boundaries of what
Mhm,
is possible with geospatial technologies, and let's say contribute to the academic community. It's like incredibly fulfilling to explore new ideas, collaborate with brilliant
mhm,
minds around. And on the other side, the industry it provides more of a dynamic environment where I can apply my research in real world scenarios, see tangible impacts, and work on some really nice projects, real world projects.
yep,
So the opportunity to bridge the gap between research and I would say I'm not more into theoretical research, but I'm more into applied research. And then the
yep,
practical applications is something I really find exciting. So, yeah, I mean, a bit of both. I would say ideally, I would love to find a role that allows me to dive into applied research and development as part of my regular
mhm,
responsibilities.
mhm,
Yeah,
mhm,
so I
mhm.
would really enjoy such roles.
And do you see this more happening after PhD is finished? In more in Germany, more in Canada, or do you see you're just completely open and you
Yeah.
next station is Mars? I don't
No,
know.
honestly, I haven't given it much thought yet. I'm just currently focused on my research and the projects I'm involved
Mhm.
in, which keeps me pretty busy. But
Step by
yeah,
step.
but yeah, I mean, both Germany and Canada have been incredible places, I would say, for professional growth, and each
Mhm.
offers unique
Mhm.
opportunities. So whether I continue in academia, go back into industry, or find a way to balance both, I'm kind of open to wherever the journey takes me.
Yeah, yeah, yeah. Yeah, so what's the next paper that you will release? What are you working on right at the moment? Can you
Uh,
even share it?
yeah, it's next. So we are focusing on integrating 3D geospatial data with socioeconomic factors and
Mhm.
residences' behaviors to create more responsive urban digital twins. So the goal is to enhance how we model and simulate energy consumptions and carbon emissions, and even the impact of urban policies on local communities. So by combining spatial data with insights into how residents live, work, of course, these are more based on statistical methods, based on literatures.
Yeah.
We try to provide more holistic view to the urban planners. So this approach more aims to make our neighborhood, I would say, not only smarter, but also
Mhm.
more attuned to the needs and behaviors of the people who live there. So
Mhm.
that
Mhm. Mhm.
is
Mhm.
what I am working right now, and I'm really looking forward to share our findings.
Very cool. Very cool. All right. Let's do a tiny little bit of philosophy before we wrap
Yeah.
up. So, we touched the topic just slightly before, but what are your personal indicators that show you that your work actually has a positive impact and that basically prove to you that yes, you are on the right track?
For me, the most significant indicator that my work is having a positive impact comes, I would say, from the community and the
Mhm.
stakeholders I'm involved with. When I see decision makers using the tools and frameworks what I or our group together have developed to make informed choices, or when I hear from colleagues and let's say collaborators that our work is helping them to solve some real world problems. So this kind of reassures me
Mhm.
that yes, I am on the right track.
Mhm.
Additionally, I think when our research papers or publications get referenced or cited, and the project
Mhm.
at the
Mhm.
end it leads to some meaningful changes or impacts or in development of some strategies, then it shows a clear sign that our work is it's actually making some difference. And yeah, I think ultimately it's about seeing the real world application of the research and knowing that it is actually contributing to making our more smarter and sustainable urban futures.
Mhm. Cool. We also touched upon this just very briefly before. Kind of what are the things that keep you going when things are tough in life?
Yeah, I think so. When the things get tough, I remind myself that setbacks are just part of a larger journey, I would say.
Mhm.
I have faced challenges before and bounced back, so I know I will do it again.
Mhm.
I think for me, there is no shame in accepting that I do give up, but then I find comfort in the idea that the setbacks are platforms for comebacks. Each struggle
Mhm.
has its own purpose, and focusing on the current goals, focusing on the things which are in my hand, and of course then the support from my wife, parents, friends, colleagues, they it helps to keep me motivated. Yeah, even when the path is not clear, I trust that these difficulties ultimately will go, and ultimately it will help me to shape better opportunities for the future.
Mhm.
So it's
Mhm.
kind of a blend of patience, hope, some beliefs, purpose that keeps moving keeps me moving forward. Yeah.
Nice. And good food, right?
Yes, of course. So I how can I forget that? Yeah.
Ah, cool. In your opinion, what is success and what is a career?
That's um very good question. So to me, let's say success is it's more of a temporal thing. It's just about reaching a specific goal or achieving a certain status. It's about making meaningful progress in areas that truly matters to me. It's
Mhm.
about finding, let's say, fulfillment in what I do and contribute positively. to those around me.
Mm-hmm.
So it's often involved in personal growth and overcoming challenges. On a career, on the other hand, is more of a journey, I would say, rather than a destination.
Yeah.
It's kind of collection of experiences, good things, bad things, roles, what we have gone through, the achievements which we accumulate over time. It's about pursuing a path, I would say, that aligns with the love, the passion, and the values. And it actually evolves with you as we grow. So it's more like a
Mm.
continuous process. It's more like a journey. And I would say there is no end point to it. And it's no, I would say it's not even temporal. It's just something which keeps going you as you go throughout your life. And it actually shaped by both the professional milestones we reach
Mm-hmm. Mm-hmm.
and the personal satisfaction I gain along the way. So yeah, probably that's how I see
Yeah.
success and career.
Nice. And what's the most important and the most satisfying aspect of teaching students and mentoring students?
Yeah, I think I really love doing that. I think the most important aspect of teaching students is seeing them grow and develop their own understanding and skills. I think it's
Mm-hmm.
incredibly fulfilling to witness students when they grasp complex concepts, apply them creatively, and then gain confidence in
Mm-hmm.
their abilities. Yeah, I mean, at one point of time, all of us were students. So just to go back in that time through the eyes of those whom we are teaching, it just gives that true satisfaction, which which comes from knowing that yes, you have played a part in their learning journey, helping them overcome obstacles and allow them to discover their true potential. So yeah.
Yeah. Oh, beautiful. Beautiful. All right. I would say we are just going to tackle the final three
Mhm.
questions that I always ask.
Yeah.
Hope you're ready.
Yeah.
All right. So, yeah, let's try to wrap this up slowly. So, if you have to recommend a book, which one would it be and why?
Let's see. So if I had to recommend one book, yeah, it would be Ikigai, the Japanese secret to a long and happy life. It is written by Hector Garcia and Francesc Miralles, I guess. So
Mhm.
the book explores the Japanese concept of Ikigai, which is the name of the book, which translates to the reason for being or purpose in life. Yeah, and I think what makes it so impactful is its focus on helping individuals find their own sense of purpose and fulfillment. It's not just about achieving success or happiness in a conventional
Mhm.
sense, but also
Mhm.
about discovering what truly motivates and inspires you, what truly brings back when you are down. And I think the book offers practical insights and reflections on how to live a more meaningful and balanced life. I think which can be incredibly valuable for anyone navigating their personal or professional journey.
Yeah, I think I should read that too,
Yeah.
especially for work-life balance.
Yeah. I think that is quite important probably in today's time. And I think also in the time going forward. Yeah.
Yeah, 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 yeah. Ah, cool, cool. Now, if you could change one thing on this planet to make it a better place, what would it be?
Wow, that's a tough question. Uh, I think it would be to encourage everyone to let go of their ego, personal ego, and work towards a more collective way of living. So it's
Mhm.
like ego, they often drives us to prioritize personal gains over the common good, yeah,
Mhm.
leading to division and conflicts. And by fostering a mindset that values collaboration, empathy, mutual support, we could actually address many of the world's issues more effectively and create a more harmonious, sustainable, livable, and equitable society. I think it's more about moving beyond self interest to embrace a shared vision of progress and well being for everyone.
Yeah, yeah. Very nice. Beautiful. Well, and then the last one. Who would you like to see as a guest on the 3D Environment podcast?
So I would like to see Christopher Gibbs from Concordia University as a guest. So he is a veterinal, I would say, gaming expert. And right now at Concordia, basically, he is within this next, I would say, next generation cities institute. He is leading, I would say, a small team of game developers. So basically, we are working more, and actually, I'm also part of that small team. So we are working on an exciting prototype for the Regional Metropolitan Transport Authority for Montreal, ARTM. And the idea is that this project will allow residents to experience their daily commuting patterns and travel routines in a future scenario, specifically when a new transit terminal is built in the downtown Montreal. So my role involves, let's say, going through various open geospatial data sets available for Montreal and generating procedural data when needed to fill in the gaps, and then providing tailor-made 2D and 3D urban data sets for Unity game engine so that the game developers, they can bring these data sets to life. Yeah, so I think because Christopher Gibbs is a veterinal gaming expert or game developer, I think his unique perspective coming from a gaming industry background and now contributing to sustainable urban development would add an innovative angle to the discussions on 3D environment and the application in this podcast.
Yeah, no, that's super cool or super good to know. By the way, I also just realized over the podcast now that there's a ton of overlap between your work and the work also of Flora Rumpani that was just a couple of weeks back on my podcast, and I think I should connect you two because there's a lot of overlap in the field, and because she's also been very heavily like quite influential in these fields, also in academia, with her research. So I think I should connect you guys. Offline.
Yeah, I think it would be a great honor because I keep on reading her work whenever I get time. So yeah, I'm kind of also influenced by her work, and it would be really, I would be very happy and really fortunate to have a conversation with her.
Yeah. No, I'll definitely organize this. Very cool. Well, it's been an absolute pleasure to have you on. Thank you so much for your time and your wisdom that you're sharing with us. And are there maybe, I don't know, last questions, last comments that you would like to share with the audience?
No, I would like to thank you so much for having me here today. As I said, I'm kind of a bit of fan struck. Following your work, your podcast. It's been a pleasure discussing the exciting intersections of geospatial technology and its impact on the society with you. And as a fan of your podcast, I'm eagerly looking forward for the next episode already. So
you're way too kind. It's just the honor is really mine to have such wonderful minds as yourself on the podcast. So I'm fortunate to be able to do this. So thank you so much. And
thank you. Thanks again for the opportunity. And I hope our conversation has been engaging for your listeners as it has been for me. So thank you so much.
It's been it for me. I cannot speak for the audience, but I think it's been wonderful. Otherwise, who would torture themselves for over 2 hours, right? All right. Thank you so much. And I would assume it's appropriate to say namaste at this point in time.
Yes.
Namaste. And one of my favorites would be palak paneer.
Oh, wow.
I love that one. It's been like 3 weeks ago I had that. It's one of my absolute favorite Indian dishes. I've had it, and I remember I got to know it when I was working in Vancouver. I worked together also with a bunch of guys from India that I spent quite some time with them, and we went to some different like Asian food, Indian food places, and palak paneer is one of my absolute favorites.
Lovely. Nice to know. Hopefully next time when we meet, you will have your palak paneer ready from me.
I'm looking forward. That sounds amazing.
Yeah.
All right. Thank you so much for everything. And yeah, let's wrap
Yeah.
it up.
Thank you so much and have a very good evening.
Thank you. You too.
Yeah.
Bye bye. Cheers.
Bye bye. Cheers.